I want to address an issue I saw a couple different times throughout the day today with using Lewis dot structures to show how electrons are transferring. So if we're using the example of potassium and oxygen, remember you've got to know how many valence electrons there are. So here's potassium. Potassium has one valence electron. You draw it like that. All right, here's the first issue. So oxygen right here has 6 valence electrons. So when you are drawing the Lewis dot structure, remember to imagine that box around it, and then remember to do 1 electron on each side until you come around and double up. So here's some of the things, here's an issue that I saw. This is incorrect. I saw 6 electrons being drawn like that. That is not correct because those are not, whether they're paired or unpaired matters. This right here is showing 3 pairs of electrons and then no unpaired electron here, and that is not correct. When we're drawing oxygen, we want to draw those 6 electrons, 1 on each side, and then coming around doubling them up. 1, 2, 3, 4, 5, 6. Now we can clearly see that there's a pair of electrons here, a pair of electrons here, unpaired electron, unpaired electron. Those unpaired electrons are where it's essentially a vacancy, where it needs to make some kind of bond, where it needs to, for ionic compounds, it's going to receive that electron. Here's the other thing I saw. When you're showing these electrons transfer, so this potassium wants to lose that electron, oxygen needs to gain 2 electrons. Here's another thing that I saw that is incorrect. I saw that here and then drawing another one here. We don't want to draw that because that's going to confuse us later going, okay, well, where did that, basically you just created another electron, which is not accurate. So we want to get rid of that, and you're always going to draw an arrow showing that this electron is lost and it's going to come into this spot right here. Do not draw it again. Just draw an arrow showing how it's transferred. Okay, so if we're going to continue this example though, potassium and oxygen, that potassium has lost its 1 electron, so this potassium's all set. It did everything it needs to do. Oxygen, though, still needs to gain another electron. Well, where is it going to get that from? We'll have another potassium with its 1 valence electron. That 1 valence electron will fill this spot. Again, I'm drawing an arrow only. I'm not creating another electron. I'm using the arrow only to show how that electron is transferring. All right, and then if we finish this up, well, this is all done now. Each of these potassiums, they got rid of the one they needed. Oxygen gained the 2 that it needs. So it's going to form potassium oxide. 2 potassiums for every 1 oxygen. That's potassium oxide. Keep an eye on those issues with electron dot structures or Lewis dot structures and showing how those electrons transfer. Make sure you are using arrows only to show how those electrons transfer. We'll be using lines later to mean something completely different.